Hi there, I'm Oliver Bergfeld and I've been in the consulting industry for more than 15 years. In the past 6 years, I've focused on the topic of Internet of Things, or IoT for short. As you might have noticed, I am using Tesla as a reference for an IoT business model. One of the drivers for me to make this video were the discussions on valuation of Tesla, especially in Q4 2019 and Q1 of this year when Tesla shares went ballistic. Tesla was constantly compared to traditional car manufacturers, and that just left me wondering if I was confused or if these analysts were not looking or not seeing the whole picture. I'm not saying that at peak valuation around $900 was fair. That could be a topic for another clip. I'm merely suggesting that the analysts' approaches were often enough analogous to comparing apples and pears. They were focusing on tangible aspects of Tesla. So the car itself, the production capacity, whatever. So in this video, I'll illustrate at an aggregate level with which components the Internet of Things can be described. And I will make the case to show why and how the comparison of a car manufacturer, Tesla, and a traditional car manufacturer is missing a large caption of innate value of Tesla. To illustrate my point, I'll start by introducing you to what I call the IoT Playground and how it can come in handy when planning or discussing taking advantage of opportunities provided by IoT technology. I chose Tesla in particular because their offering checks many boxes in the Internet of Things space, which can't really, at least at this stage, be said for many other car manufacturers. As a German and living in Germany, I've been getting quite some pushback on my views on Tesla, as might not be surprising. Nevertheless, I've noticed whenever I'm given the time to elaborate, the pushback tends to ebb away. So on these tailwinds, let's begin. I like to structure things, and in the past, it has proven helpful when trying to understand, wrap your head around more complex issues that breaking these down into relatable bits and pieces delivers a far better understanding of what the whole end-to-end picture looks like. And that's exactly what I did for the Internet of Things. And this is what got me to what I call the IoT Playground. Basically, it clusters a skill set into individual domains. So an IoT offering can thus be broken down into 7 different domains, industries, and services. From left to right, each and every domain can be seen as an area of expertise that requires a certain skill set that is distinct from other domains. Starting with the initial domain number 1, this is where you define the industry you want to take a closer look at. In our example, the automotive industry. Well, you could say we're looking at transport sector as a whole, but to get started, let's just start out with cars. Subsequently, some of the other domains, depending on the industry you selected as domain number 1, might become more or less critical for the offer you're trying to develop. So if you're trying to develop an electric mobility offer, or an electric car for lack of a better term, aside of the obvious need for standard requirements such as a factory, a robot, personnel, etc. to build a car, you'll need to define and build a chassis, a car body, and a drivetrain, which I'll refer to as traditional 3 components. On top of these, to make it an IoT offering, you'll also require sensors, software, and connectivity. So sensors, you're looking at camera, radar, maybe even a gyro. Software, you're looking at software design and software architecture. Connectivity, you'll have to answer to questions of bandwidth and coverage. These newer additions to building a car require a new suite of questions to be answered. For example, what kind of sensors do I need? Or to go even further back, what do I want to enable the car to do? Subsequently, you'll need to answer the question, what kind of sensor suite will be able to deliver the desired capabilities? After all these questions, you'll need to look at the software. What kind of design, what kind of architecture is best suited? How can it be secured sufficiently? How can you ensure that software patches are possible so that there's no need to update the entire software stack? Or which part of the software stack can be updated while the car is in motion, so which part is non-critical? Last but not least, what kind of connectivity is required to best deliver the gathered data? Every use case will have a minimum bandwidth requirement. So, like for instance, an emergency call, you'll need 2G. That'll be sufficient. But if you're looking at supporting use cases like live streaming of HD video, you're looking at more LTE or 4G. Plus, sufficient data pass tariff will be in order when traveling. To wrap up, these newer components need to be integrated into the three classical components: chassis, body, and drivetrain. And the depth of integration is crucial, as these are not just additions to the car, as they have been in the past. These require a whole new set of different lines of thinking. So we're looking at least a 90-degree, if not a 180-degree shift from traditional auto manufacturing. First, you'll need to think of the why, and then you'll think of the what, and then the how. And there are several challenges posed by these new components, which I'm leaving out for now. Otherwise, this video would turn out to be a little too long. But I can dedicate a new video to address some of the issues if you like. Domain 2 and 3 cover connectivity as mentioned before. As soon as you know which use cases you want to support, the requirements for the connectivity will result. Also, if you're looking for the opportunity to do larger software updates, Wi-Fi might be the connectivity of choice, because the update could otherwise end up consuming the entire data of the mobile tariff. But you could implement a business logic within the car. That would only start an update if the battery is low, the car is stationary and charging, as well as the car is connected to the home Wi-Fi. Domain number 4, cloud domain. So here you'll need to decide, for example, how many concurrent users, that's users at the same time, you need to support. This in turn will give you an idea of how much compute power you'll need, or whatever kind of additional services you would like to provide to your customer to ensure the customer experience you're looking for. As mentioned before, these parameters are the result of the use cases you've designed, as well as the scaling or planned growth for the user base. For now, this is one domain, but in future it could be broken down to further domains, because infrastructure as a service offering is very different from a software as a service offering. But for a general overview, this should be sufficient for now. Domain number 5, the service layer domain. This is basically your administration layer to administrate your connectivity. This can be built into the customer interface, allowing the customer to upgrade or downgrade their car connectivity. But for security reasons, some parts may not be made available to the customers to administrate. So for instance, you might want to restrict that the customer can fully opt out. Domain number 6, data and application domain. This is where you define your interfaces or software development kits that enable the onboarding and integration of over-the-air applications, such as, for instance, Spotify, Netflix, or Apple TV for that matter. This way, you can fully integrate these services into your onboard unit so that you won't have to visit the individual websites to use these or access these servers. You can just click on the icon on your dash, and that will start up the individual application. Domain number 7, the enterprise systems domain. This enables deeper integration of suppliers, for instance, into the customer ordering process. So in our scenario of the customer could then purchase an entertainment bundle that has high bandwidth mobile data tariff included, a video offering, Netflix, Apple TV, online gaming, maybe Stadia from Google, and that all is pre-installed and pre-configured for 12 months. The car would then be delivered pre-configured to the customer. You could spin the idea even further, maybe including peripheral equipment like controllers, screens for the headrests, and all that, bundled in. Advantage for the customer, she would not have to do any research and purchase and configuration separately. And the obvious advantage for Tesla is additional profit margins and higher customer satisfaction. Surely these concepts would need to be validated, so you'd need to verify that the additional effort for integration, etc., would be covered by additional revenues, so the entire effort could be deemed justifiable. Maybe this is not the case right now, but in future with a larger customer base, I'm positive this could work out. Now, having run through all these domains, I sincerely hope it's become quite evident that many, if not most, are not hardware-related issues, but software-enabled, or even better, software-driven. This is then the crux and the main challenge for the traditional car manufacturers. The actual car is not the issue. To be very clear, there are no major shortcomings with Tesla cars. I am positive that the upmarket or luxury manufacturers will come up with very good or even better built electric cars by comparison. Getting back to the three traditional components, chassis, car body, and drivetrain, they have clear advantages when it comes to production capacity and build quality for chassis and body. The drivetrain, on the other hand, be it battery and motor, is and likely will remain the challenge for some time to come. But even this is missing the picture. The main tricks lie in the software, the non-tangible part of a Tesla. So even if the other car manufacturers can catch up, the lead will remain until the software challenge is fully addressed. So we will see how far Tesla can expand its lead on Battery Day. I hope you guys enjoyed my take on the issue. It'd be great if you could give me a thumbs up and maybe even a subscription. I've got some more clips in waiting. Also, if you had feedback or questions, please do drop me a comment below, and I will get back to you. Thank you for your time. Take care, and as we say in Germany, tschüss.